Are you giving away more than your customers are paying for? You might not even make them happy, but you're definitely increasing your own cost. And that actually might make your customers unhappy in the longer run. Hello, I'm Tom. Welcome to my channel, where we talk about continuous improvement in an industrial setting. And this video is about overusage. It's one of the 5 material and quality losses. So you've got your overusage, scrap, defects, off specs, and claims from our customers. Now, overuse is when you give too much away to the customer, or when you use too much stuff to make your product, but it basically stays with the product. So when you have way too much material and you cut something off, that's when we're talking about scrap. Overuse is usually difficult to spot because the product itself is good. There's no off spec, there's no defect in it, but it has a bit more. So perhaps you just put too much in the product, or, and this one we'll get back to as well, perhaps you're using too much in the product, in the process, but this is a more difficult one. But usually what we're talking about is when we promise our customers something and we deliver, well, at least that amount because we're required to, but we over deliver. And sometimes they like that we over deliver, sometimes they don't even notice, but in both cases we are increasing our own price. If we have some drink syrup and this syrup claims that there is at least 80% pear juice in the syrup and it is 1 liter. Now, basically what we have here are already sort of specs, but this is what we promise to our customer, and in the daily practice of many big manufacturers, what we'll see is that this promise is calculated into specifications by a product technologist or research and development technologist. This type of people, type of department usually sets specs for the production organization. But it's good to know that in the end, the specs are to make sure that the customer gets what we promise them. So it's making good on a promise. Now, in this one, the basic examples are, if we have more than 1 liter in our bottles, on average, we are giving away too much product. And I did a video about e-weight, the European system, where you can in fact get very close to the 1 liter, because if your spread is low enough, you can actually manage to get exactly there with sometimes a little bit under and the same amount of time a little bit over. But what we see mostly in practice is that the spread in our systems is so large that to compensate for those few times that we go under a little bit, we move the average to have a bit more in our containers so that we do not get this too low product thingy. In other countries, you simply have law stating that if there is 1 liter on the package, there has to be at least 1 liter in there. So with spread in your system, you have to go up. But this is definitely overuse. You do it to make sure that you are always up to specs, but on average, you are using more. And the other one here also, we assume that if you put there that it's very nice 80% pear juice, then probably this is your most costly component, or at least this is a component that you promise to your customers. So it has to be in there at least 80%. Again, with the variation in the process, at least in practice means that we have to put in a bit more. This will also, from time to time, go a bit in the other way. And a nice example of history changing is what we have in my business, the cheese business, where many cheeses will have a fat content number. But in fact, within the cheese composition, protein is more expensive than fat. So there is also a maximum range to this fat, and here you see that what you promise the customer is also regulated by trade organizations or by law or by product quality standards, and then your technologist, together with the competent authorities, they make the specs so that the customer is still getting what they expect, are protected. And that's why I put here not what do we put on the label, but how does this translate into production specifications. Now, in some industries, we talk about yield, well, actually in many industries we talk about yield, but the problem with yield is that you say something, for instance, like we need 16 kilos of pears to make 1 liter of concentrate juice. And when we use 18 kilos of pears to make that 1 liter, we have a low yield. It did not yield the proper amount of product. So there is a problem. This is not always overuse. Quite often, this can also be that we cut off too much, or that we had to scrap a batch, or that we had to clean tanks. These are all scrap and defect type of wastes. But of course, yes, also overfilling is a good reason to have a problem with your yield. So yield is a bit too broad. But there are also industries like glass fiber, for instance, where there is this cooking and mixing process where, well, in the chemics involved in that, you may actually lose material. It basically means it flies up into the air, but still, there is no scrap coming off. There is not too much weight in your final glass fiber product. It just evaporated, quite literally. So that part of yield, where you say we simply put in too much, we do not get it out as a physical product, neither as a good product nor as a scrap stream, yes, that part of yield goes into overusage. And a very common thing we will see in practice, and in fact I made a video about it also, it's about giveaway versus scrap. A very short summary here. We almost always have variability in our process. So we take this liter here. We have some law saying if you put 1 liter you can be slightly under, but not a lot. We have a high spread. So what are we going to do? Are we going to make overuse, giveaway, by moving our center a little bit to the right and putting a bit more into each package on average so that this tail moves out and we don't have to scrap anything? Or are we going to move the center more closely to our target norm, to our specifications, and accept a bit more defects to make sure that the big mass of our product is not giving away too much? Very interesting, slightly involved calculations, but they can really get you a lot of money if you do it right, or cost you a lot of money if you always go for one or the other. And here you also see that different parts of your specs are very important for what you do. When calculating overuse, the spec line that you put here is important, but also the reason why we have this balance in the first place is that another part of the specs says what is a defect, what is allowable and what is not allowable. Very important to get these very clear, very correct. So as a sort of an added bonus, when you start analyzing material losses, mass balances, quality costs, and you notice that the specs are hard to find or difficult to read or simply unclear, or you have different specs with different people within the organization, that has to be a huge alarm. And it may not be a material loss by itself, but when you are doing a loss analysis, flag it, because that is a problem your company will want to solve. You need clear specs before you can really steer your processes, but also before you can say what is good or bad or what an operator needs to do. But okay, that's a different topic. This is about overuse. Basically, I think it's an easy loss to understand. It's a hard loss to eradicate. Now, let me know if you like this video by hitting that like button, and also tell me what parts of overusage or any other loss would you have me explain a bit deeper. Drop me a comment. I love to read them, and I'll also be happy to make additional videos about the topics that interest you. But for now, I wish you the best of luck reducing your overusage, and as always, enjoy the journey.